we are going to look at Chapter 6, Lesson 2, Speed and Velocity. When we are done with this lesson that starts on page 218, we are going to know how do you calculate speed, how do you describe velocity, and how do you graph motion. So get your books, grab a highlighter, grab a pencil, and let's start on page 218 and let's read. All right, like always, we're going to start off with the My Planet Diary, and this was posted by Mallory, who lives in Fountain Valley, California. Once my sister talked me into going to a roller skating ring with her. I hate skating, but against my better judgment, I agreed to go. I can skate, but I don't go very fast. At the rink, there were these speed skaters, or as I like to call them, assassin skaters. The assassin skaters were ridiculously fast. They were probably going approximately 20 miles per hour at the same direction as me. They zipped past me, just barely missing me. The worst part about going skating was getting stuck behind a group or a couple. They were going so slowly that you had to speed up to get around them. All right, so the first question asks, do all the skaters in the rink move at the same speed? Explain. And then number 2 asks, describe a sport or activity in which speed is important. So go ahead right now, answer those questions, and then move on. So let's talk about how do you calculate speed. You might describe the motion of an airplane as fast or the motion of a snail as slow. By using these words, you are describing the object's speed. The speed of an object is the distance the object moves per unit of time. Speed is a type of rate. I want you to highlight the definition of speed. So the speed of an object is the distance the object moves per unit of time. What that means is that it's the distance it takes for something to move per time. So a rate tells you the amount of something that occurs or change in 1 unit of time. The equation for the speed equation. To calculate the speed of an object, divide the distance the object travels by the amount of time it takes to travel that distance. The relationship can be written as an equation. So speed equals distance divided by time. So I want you to highlight the bold-faced words. And then take your pencil, I'm going to take a pen, and I want you to just circle that equation. So to calculate the speed of an object, divide the distance it travels by the amount of time it takes to travel. So you just do distance divided by time, and that's it. The speed equation contains a unit of distance divided by a unit of time. If you measure the distance in meters and time in seconds, the SI unit for speed is meters per second, or m/s. The S is read, or the slash is read as per. So I want you to highlight just the if you measure distance, this one. That way you know how to label, because labels are going to be very important. Labels are always very important in science, but now that we're getting into doing calculations, they're going to be even more important. For example, at its cruising altitude, an airplane might travel at a constant speed of 260 meters per second. This means that the airplane will travel a distance of 260 meters in 1 second. The speed of a snail is about 1 millimeter per second. This means that the snail will travel at a distance of 1 millimeter in 1 second. The speed of an airplane is much greater than the speed of a snail because the airplane travels much faster than the snail in the same amount of time. All right, you guys are going to do the apply it question. So I want you to do this question. It says the cyclist is shown in the diagram below going at a constant speed of 10 meters per second during her ride. So that means she's every second she's going 10 meters. So draw arrows on the scale to mark how far the cyclist travels 1, 2, 3, 3.5, and 4 seconds. And then the challenge question is how long will it take for the cyclist to travel 400 meters? When you're done with that, unpause the video and turn the page and continue on with us. So now we're going to talk about average speed. So this is a little different than normal speed. When a plane is at its cruising altitude, it can travel at a constant speed for many hours, but the speed of most moving objects is not constant. In a race known as a triathlon, the competitors, or triathletes, first swim, then bike, and finally run. The speed of triathletes change throughout the race. They travel slowly when they swim, a little faster when they run, and fastest when they bike. Although the triathletes do not travel at a constant speed, they do have an average speed throughout the race. To calculate average speed, you divide the total distance traveled by the total time. So I want you to highlight that. To calculate average speed, you divide the total distance traveled by the total time. For example, suppose a triathlete swims a distance of 3 kilometers in 1 hour. Then the triathlete bikes a distance of 50 kilometers in 3 hours. Finally, the triathlete runs a distance of 12 kilometers in 1 hour. The average speed of the triathletes in total distance divided by time. So the total distance, you would add the 3 kilometers, the 50 kilometers, and the 12 kilometers, you would get the 65 kilometers because it was 3 kilometers to swim, 50 kilometers to bike, and 12 kilometers to run. And then you would do the total time. 1 plus 3 plus 1 is 5. So the average speed, you would do the distance, 65 divided by 5. So the average speed would be the 35 kilometers per hour. So I want you guys to take a minute and try and figure out the average speed for this one and this one. So over here, we read, this is the directions up here. So figure 1 says triathlete A and B are competing in a triathlon. The first 2 legs of the race are biking and swimming. Use the data in the boxes below to calculate each triathlete's average speed during the swimming and biking legs of the race. So you have your total distance, and then you have their times. Triathlete A, triathlete B. Total distance, A and B. Go ahead, take a minute and do that, and then move on. Now we're going to look at instantaneous speed. Suppose triathlete B passes triathlete A during the biking leg. That means like the biking segment. At that moment, triathlete B has a greater instantaneous speed than triathlete A. Instantaneous speed is the speed at which an object is moving at any given instant time. Highlight the definition for that. So what that means is at that given time, that's when that person or that thing, that object has a greater speed. It is important not to confuse instantaneous speed with average speed. The triathlete with the greatest average speed, not the greatest instantaneous speed, wins the race. I'm actually going to have you guys skip this apply it and go to the next page. On this page, we're going to look at velocity. So velocity is a little different than just talking about speed, okay? So we're going to talk about how do you describe velocity. So knowing the speed at which something travels does not tell you everything about its motion. To describe an object's motion, you also need to know its direction. I want you to highlight that because it's very important to know that you also need to know direction. You can't just say, oh, it's moving fast. Well, which way is it moving fast? For example, suppose you hear that a thunderstorm is traveling at a speed of 25 kilometers per hour. Should you be prepared for a storm? That depends on the direction of the storm's motion. Because storms usually travel from west to east in the United States, you probably need to worry if you live west of the storm. You need not to worry if you live west of the storm. You probably should take cover if you live east of the storm. When you know both the speed and direction of an object's motion, you know the velocity of the object. Speed in a given direction is called velocity. Highlight that. That is the definition of velocity. Speed in a given direction. You know the velocity of the storm when you know that it is moving 25 kilometers per hour eastward. At times, describing the velocity of moving objects can be very important. For example, air traffic controllers must keep close track of velocities of aircraft under their control. These velocities change as airplanes move overhead and on runways. An error in determining velocity, either in speed or in direction, can lead to a collision. Velocity is also important to airplane pilots. For example, the stunt pilots in Figure 2 make spectacular use of their control over the velocity of their aircraft. Stunt pilots use this control to stay in close formation while flying graceful maneuvers at high speeds. I want you guys to answer this question down here. It says, these stunt pilots are performing at an air show. Why is velocity and not just speed important to these pilots? I'm going to have you skip this page, and we're going to talk about motion graphs. I'm just going to read through this, and because we're going to actually spend an entire day with motion graphs and how to work with them. So we're going to read through this, we're going to highlight the information, and then we are going to actually spend an entire day working with how to graph motion graphs, how to read motion graphs, and things like that. So if it seems like we're kind of going quickly through it, that's why, because we will spend an entire day how to read them, how to make them, how to use them, and things like that. So let's read and highlight and find the information that we need to know. How do you graph motion? The graph you see in Figure 4 and 5 are distance versus time motion graphs. You can show the motion of an object on a line graph in which you plot distance versus time. I want you to highlight that, because I want you to know that it's always going to be a distance versus time that we are going to use in 6th grade, and it's always going to be a line graph. Okay? By tradition, time is always shown on the horizontal x-axis. Distance is always shown on the vertical y-axis. Very important to know. Distance is always on the y, which goes up and down. Time is always on the x, which goes side to side. A point on the line represents the distance an object traveled during a particular time. The x value of the point is time. The y value is distance. The steepness of the line graph is called the slope. Go ahead and highlight that. The slope tells how fast one variable changes in relation to the other variable in the graph. In other words, slope tells you the rate of change. Since speed is the rate that distance changes in relation to time, the slope of the distance versus time graph represents speed. Highlight that. The steeper the slope, the greater the speed. At constant slope, a constant slope represents motion at a constant speed. So we're going to talk about calculating slope. You can calculate the slope of a line by dividing the rise over run. The rise is the vertical distance between 2 points on a line. The run is the horizontal distance between 2 points. The run is the horizontal difference between the same 2 points. So the rise is the vertical distance between any 2 points on a line. Run is the horizontal difference between the same 2 points. And then again, take your pencil and circle that formula. In figure 4, using the points shown, the rise is 400 meters, so figure 4 is down here. The rise is 400 meters and the run is 2 minutes. To find the slope, you divide 400 meters by 2. The slope is 200 meters per minute. So what they did was they took this point here and this point here. They took the difference between, they took the vertical distance between any 2 points, which was the vertical distance, which is this number minus this number. So they did 1,200 minus 800, and they got 400. That was their rise. And then they took the horizontal distance, which was 6 and 4, and they did 6 minus 4, and that's where they got the 2. And then they took the 400 and divided it by 2. So that's how they got that. Once again, don't freak out. We are going to take all kinds of time, a whole day, and talk about this. So the speed of the jogger in this graph would be 200 meters per minute. Let's talk about this one. Most objects do not travel at a constant speed. For example, in figure 5, this shows a jogger whose motion on the second day of training. The line is divided into 3 segments. The slope of each segment is different. From the steepness of the slope, you can tell that the jogger ran fast during the 3rd segment. The horizontal line in the 2nd segment shows the jogger's distance does not change. The jogger was resting during the 2nd segment. Okay, so what that means is the jogger started off, the jogger took a rest, and the jogger ran fast again. Okay, I'm going to have you skip this because I'm actually going to put this part in the PowerPoint when we talk more about it, because this video is already 20 minutes long. I don't want to go through this with you right now. When we do, I don't like when you guys can't see me when we talk, even though it's really hard to see me right now. How about we do this? Better? Better, now you can see my face. Okay, so I'm going to actually upload that kind of like picture thing to the PowerPoint when I talk about motion graphs, and we'll do those questions when we talk about motion graphs. That way you guys aren't kind of overloaded with all kinds of information right now. So do those questions that I told you to do. Skip the questions on this page. You don't have to answer the questions on this page. Just highlight what I told you to highlight. And then when we talk about motion graphs, we'll do more questions on those. So highlight, answer the questions. Let me know if you guys have any questions. If not, I hope you have a great day. Enjoy the rest of your day. If you're watching this on Friday, have a great weekend. If you're watching this on Monday, I'll see you tomorrow in class, Cohort B. All right. Enjoy your day, enjoy your weekend, and see you later.